Hello, in this video I'm going to introduce the idea of loops in your Python program. Let's go first of all and look a little bit conceptually at what we're doing here. So I'll bring up my little Paint program. And those of you that have attended my classes will know that I introduce a diagram just briefly called a Nazi-Schneiderman. So I'll just draw very roughly here on my screen what one looks like. And we've got, as you can see, 3 boxes here underneath one box at the top. And the box at the top is actually the name of our program. So let's call this one counting. And then we have 3 boxes underneath, and each one of these boxes has a label as well. So this one is initialize. So these are the things that get done once at the beginning of our program. Then we have a part here which we're going to call main. This box is about the main purpose of our program. What's the reason why we're there? So if we were typing a Word document, for example, we could say initialize might involve all those things like, you know, opening Word and loading our document and drawing the toolbar and all the sorts of things that we want. The main part might be about the doing bit, actually typing our letter. Of course, at some point we're going to finish our letter, and then there are a few things we might want to do once at the end of our program, which is the terminate phase. So for example, we might want to save our letter so we don't lose it. So these are the 3 basic parts that make up, in this case using Word, but it could be any program really that you can think of. Each one of these is joined together. So we go back here, I'll just draw those for you. So we have a join there, there, and there. And that works pretty well. There's one important part that's missing out of this diagram that we need to cover, and that is, if I'm in the initialize bit, okay, I set things up, I start Word, I open my letter, my document that I want to work with, and then I go to the main part of the program, which is the middle box, and I start typing my letter. I need to move on from that to the terminate phase at some point. And the way that these diagrams work at the moment, I can't really do that. I sort of get stuck in this main bit. And that's not what I want to do. I want to keep typing, so I want to keep repeating the same step, typing my letter, but at some point I want something to change. And that something that changes is going to take me from typing a letter to saving the letter and leaving Word. And that change is what we call a condition. So we represent that in our diagram by drawing a little loop with an arrow on it. And we say that something changes inside the main part of our program that causes us to move on to the terminate phase. Again, in our letter, that might be we finished typing our letter. Maybe it means we've run out of time and we just want to save where we're up to because we have to come back and finish off writing our letter another time. But whatever it might be, there's going to be something that's going to cause us to stop at that point. So let's take that idea and apply that to a little Python program that we might want to write. Let's say that we'd like to write a program that's going to count from 1 to 10. So initialize was going to involve printing the first value. The main bit is going to be about adding 1 to the value and displaying the new number. That's how we're going to go from 1 to 2 to 3 and so on. And when we finish the program, we'd like to bring something up on the screen to let the user know that the program's finished. So how about we bring up all done? So that's conceptually what we're going to do. Let's have a look and see how that might work inside a real Python program. So I'll go ahead and start up Python. Remember, we get 2 parts, which is the shell, and then I'm going to go File, New File, which brings up our text editor. Okay, so first thing I need to think about is loops. How do you do a loop in Python? I'm going to first of all give you an example of a loop that's called an infinite loop. In other words, it's not going to have an ending like our counting program will. Our counting program should end when it gets to 10. But this first example of a loop I'm going to do is just going to go on forever until we forcibly stop it. So the loop that we're going to do is called a while loop. And a while loop has a condition. Remember that little circle or the little curved arrow I did? That was the condition in our diagram. Something had to change in the main part to let us end. Well, the while loop's got the same idea. You can keep doing this loop until something changes and we stop. I don't want it to change. I want this to go on forever in this first example. So I'm going to put the word true inside the while loop. And then finally I'm going to put a semicolon on the end. Now what I've just done is written a valid while loop. It's a valid Python program. It will go into an endless loop and it will do pretty much nothing. We're not going to see anything on the screen at the moment because we don't have any print statement, so we really don't have any way of knowing that this is actually working. So I'm going to add an extra line to print something to the screen so I can see that it's actually doing something. So I'll press enter and go to the next line. And this is when something rather interesting happens that we haven't seen before in our first Python program we did with variables. And that is that the cursor hasn't gone back to the far left hand side of the editor. In fact, it's indented. And that's actually quite deliberate. The way that we can work out what code belongs to the while loop is that code that belongs to the while loop is indented. Let me better explain to you what I mean here. So if I just start by doing a print statement and I print a string value, so let's just say looping here, like so, that's inside the while loop, and I can tell that with a lot of confidence because it's indented. Before I add any more code though, let's just see what that might look like. So I'm going to press F5, save my code as while exercise, and run it. And sure enough, you can see it there, our code is happily looping away. You can just see it updating down here. It's happening quite quickly, so you just see a little bit of a flicker there on the video, hopefully, that indicates that that's in a continuous, never-ending loop. Of course, I don't want it to do that forever and a day, so what I'm going to do is hold down the control key and press C, which causes an interrupt, and that will stop the program. So if you ever get a program that seems to just go on forever and that wasn't your intention, do control C and that will stop it. Let's go back to our code now and have a look at it again. So okay, so we've got while true print. How do we know when the loop is finished? Well, let me try putting another print statement in. Well, I know that print statement looks pretty good to me. I've done a few of them now, and that looks certainly the same as the previous one, which I know worked. So let's see what happens when we run that. Well, not much. We've still got that looping here message updating, but I can't see anything about my all done. And I'm back on that endless loop again. So I'll do Control C and stop the program. And I was kind of hoping I'd see all done at this point, but even that didn't show up. So let's look at the code and try and figure out what's going on here. Well, if you think about it logically the way that the computer thinks about it, the computer started a loop, it was set to true, so that means it'll go for infinity, or at least as long as we've got power from my laptop here, and we're going to print a message out while it's looping. This print statement was not indented, so that says that this print statement only happens after the loop has finished. But of course at the moment the loop doesn't finish because it's set to true. So in fact we'll never see this message, because when we do Control C we stop the program here. We don't stop the program here or after it. So how can I be absolutely sure that that print statement all done is really not part of the loop, even if I didn't know about the indentations? Well, let's try this. I've now indented all done. Have a think for a minute about what you think is now going to happen when we run this program. Are we just going to see looping here? Are we going to see all done? Let's have a go and see what happens. We'll press F5. Okay, and now we get both messages. Now I appreciate it's a little bit hard to see on the video, but it is actually saying looping here, all done, and then just cycling both those messages on the screen. Control C. Again, let's go back to the code. Let's not indent the all done line. Run the program again. And now we're just back to looping here. It's ignoring that all done print statement because that only happens when the loop is finished. Now might be a good time for you to pause the video and actually try something out like this for yourself and just see if you can get it up and going. When you've had a go at it, come back to the video and we'll show you how we can modify the while loop. Okay, welcome back. Now that we've got our while loop going and it's in an infinite one, let's make it a little bit smarter than that, and let's actually get it to do some counting for us. Now we know from the first video that we can create variables and that we can change the contents of those variables very easily if we want to. So I'm going to create a variable called x. Why is it called x? Well, it could be called count, it could be called c, it could be anything I want. I'm using x because it's just a very common variable name you'll see for this kind of thing, and it's simple to type and what the heck. So we've got x, and I'm going to set it to a value. Now if I don't set x to a value, it by default would be 0, because when computers count and computer programs count, they actually don't start at 1 like we normally were taught to do at school. They start at 0. So I don't really need to say x equals 0 like I've done here, but I'm just being nice. I think it looks nice to do it that way. So I'm going to say that's the initial value of a variable called x. Now I know my while loop is in an endless loop because of this bit that I wrote called true. Because if it's always true, the condition is always true, which is what's inside the brackets here, then we just loop infinitely. Now I don't want that. What I'd like the loop to do is check to see what the value of x is and see if it's less than or equal to, let's say, 10. Okay, so now we have a condition on our while loop that actually is checking to see if x is under a certain value. So that's looking kind of more what I want. Let's change our message from looping here to the value of x is, and then let's add and display the value of x. We learnt this again from the earlier video on introduction to variables. Sorry, if I put the x, wasn't it? So if I put that in there, we can see we've got a string at the beginning, the value of x is, and then at the end of it we append onto that string the variable, the contents of the variable x. Alright, looks interesting, so let's give it a run and just see what we get as a result. Okay, can't convert integer object to string implicitly. Let's go back and have a look at our code and see if we can see what that means. Now if you've done a bit of programming over the years as I have, that actually is quite a meaningful message, but if you haven't, well, that could be kind of confusing. So let me explain what that's actually saying. I'm going to talk about a solution to this problem in a future video, but I want to explain that error message now because you may well come across it. Basically, we created a variable called x, and I assigned it a value of 0. Notice I didn't put 0 in quotes. Okay, so if I put it like that, then the variable x would be a string variable. It would expect a combination of letters, numbers, or characters. But I didn't do that. I just typed 0. And when I did that, I told Python that that variable is not in fact going to store a string, it's going to store a number. Now there are different types of numbers that Python understands, but for now all we need to know is it's storing a number. the sort of number you can add one to, or take one away from, or multiply, or do whatever you want to do with. So that works okay. When we get to the print statement, well, print statements print strings. So it had no problem with the first part because that is a string, it's in quotes, and that works fine. But then we put plus x on the end and we said we want you to print x. And it's like, I can't do that because the first part of what you told me to do in print is a string, but the second part of what you told me to print, the value of x, isn't a string, it's a number. It's something different. And if you go back to our error message, you can see it's trying to tell us that. It's saying you've got a thing called int, which stands for integer, a number, and you're trying to use it as a string. And you're doing that implicitly. In other words, you're not telling me how to convert it, you're just trying to do this, and I don't know what to do. So that's what that error message is trying to tell us. We can fix it up later, but for now, I'm just going to leave that little bit out, and I'll show you a trick later on we can use to actually do this. So instead, I'm going to put x. Let's see what happens when I just do x. Say OK. Oh, that's interesting. Well, it's still a number, but now it's printing. And I thought just a few seconds ago that I said that it can't print if it's not a string. So how did that happen? Well, there's a couple of tricks inside Python, and indeed inside most computer languages, where the program gets a bit smart and actually does some of the work for you. So there's shortcuts if you want to think of it that way. And one of the shortcuts here is I said print x, and it went, well, x actually is a number, but you haven't got anything else here, so I guess you really do want to print it, so I'll just print it, that's fine. If I had a string and a number, then I'd have to put some more code in to tell it to convert the whole lot to a string. In this case, it figured it out for itself and it was okay with it because I wasn't mixing and matching things in the print statement. And that's the key thing. I wasn't trying to take a string and a number in the one print statement and make them work together. I just had either a string or I just had a number, in which case the print was fine. Alright, so when we ran it, we saw that it printed out the value 0. And if you think about it and look at the logic of the program, that's exactly what I'm telling it to do. I set x to a value of 0. I check if x is less than 10. In other words, is 0 less than or equal to 10? And the answer is, well, yes it is. So the condition is true. So then it goes inside the loop and prints the value of x, which is, of course, 0. That's the end of the loop, so it goes back up to the top of the while and asks the question again. Is x, which is 0, less than or equal to 10? Yes it is. So it goes back in and prints x, which is 0. So all I've done here really at this point is make myself another infinite loop that's just going to go round and round in circles because x is always going to be equal to 0. What I need to do obviously is make x go up by 1 every time I do a loop so that we don't get stuck on 0, but it goes 0, 1, 2, 3, 4 and so on. Very easy to do in Python. First of all, I put the name of the variable, x, and I say it equals itself at the moment, which is 0, plus 1. So it takes the contents of x, 0 at the moment, and then adds 1 to it, which gives me 1. And it puts 1 back into x. Let's press F5 and see if that works for us. Well, that's certainly looking a lot better, and we had a few interesting things happen all in one go just by making that change. Let's have a look at the count. We started at 0 and we counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we also saw for the first time the all done message at the bottom of our while loop. That's looking pretty good. Of course, I wanted to count from 1 to 10 and not from 0. So I might have to go back and make a couple more changes and see what happens. Now this idea of running your program, seeing what the output is and making changes is a very common thing you do in coding. When you get more experience, you can write a lot of code and it will work exactly the way you hoped it would. But even experienced developers often have to go back, run their programs, see what happens and make changes. So it's not unusual at all, and particularly when you're learning, you're going to be doing a lot of this as you learn more about what each change you make does to your program. Because even some very subtle changes can have a very big difference, as you saw by just adding that one line of code. Okay, let's go to our first line where we set up the value of x to be initialized to 0. And let's change that to 1. I'm not going to make any other changes to the code. Press F5 and run that and see what we get. And we've got exactly what we wanted now. 1, 2, 3, 4, up to 10, and then a message all done. So now we can get our computer to loop as many times as we want it to, and in this case we're printing it out as it goes. Pretty cool. Interesting enough, you can do some other fun things with the while loop as well. For example, you could get the program to count backwards from 10 back to 0, or from 10 back to 1 if you prefer. So that's going to be one of the exercises I'm going to leave you to think about. How could I change that so that this counts by starting at 10, and counting back to 1? Also, I want you to think about how could I get this to count, say, from 2 to 20, but counting in 2s. So it goes 2, 4, 6, 8, 10, so forth until it gets to 20. Have a go at writing some code using the while loop. Look at this example that I've got up on the screen now to get you started, and see if you can get your program to count backwards from 10 back to 1, and also get it to count from 2 forward to 20, but counting in 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It's not as hard as you might think. You'll have to have a little bit of a play with it, and I'm sure you'll figure it out.